Thank you, Keith. Good afternoon, all. I'm Andy Fidler, a Principal Network Architect in BT Technology. In previous UKNOF presentations, I've focused on the pros and cons of encrypted DNS. Today, I'm keen to widen these discussions to the impact of MAC randomization and encrypted hello. So let's start with the background to MAC addresses. MAC addresses are 48-bit unique identifiers assigned to network interfaces. The first half identifying the device manufacturer and the second half the actual interface. It's standardized by the IEEE and is visible unencrypted in Wi-Fi polling and connection handshakes. To enhance privacy, the IEEE, applications and operating systems have started to introduce various forms of randomization. Like other internet protocols, and here's a similarity with DNS and DNS over HTTPS, ISPs and network operators have come to rely on MAC addresses for wider uses related to customer experience, for example, automatic Wi-Fi connection, access control, and customer support applications and troubleshooting. During this presentation, I'm going to outline some thoughts on how we can balance MAC randomization privacy features with potential unintended consequences on the network and customer experience. So now moving on to the many forms of MAC address evolution, starting with the original approach. Here we have no randomization, with devices always using the same permanent MAC address for both Wi-Fi polling and probe requests. So there's no privacy through randomization and clearly no impact to the ISPs and network operators. Then the first phase of the evolution was for some devices to randomize the MAC addresses for probe requests only, but still use their permanent MAC addresses for Wi-Fi connections. This offers some form of privacy, but with no impact to the ISPs or network operators, as a device that's still using the same permanent MAC address for connections. Now we come to the second phase of the evolution. And here we have some devices, they start to randomize for the MAC address on the probe request and for added privacy on the connection on a per SSID realm basis, but always reuse the same MAC address for subsequent connections to that same SSID. For example, when connecting to a home SSID, some devices will create a random MAC address and then repeatedly use this for connections to just that SSID. This gives more privacy, but still no impact to the ISPs and network operators, as again, it's the same MAC address is always used for the same SSID connection. Now it starts to get interesting on the third stage of this evolution, because the latest form of this evolution is potentially randomizing connection MAC addresses now on a per session basis or a daily basis for full privacy. Meaning that if I connect to BT Wi-Fi tomorrow, I could have a different MAC address to that of today. Currently, Microsoft Windows 10 appears to have an option for random MAC addresses in Wi-Fi network settings, allowing off, on, or change daily options. Apple have made announcements through their recent worldwide developer conference on iOS 14 plans around private Wi-Fi. Yes, both of these will maximize privacy, but could they create unintended consequences for ISPs and network operators in terms of hotspot seamless MAC authentication, time of day access controls, device-based parental controls, and regulatory obligations? So focusing more on the key impacted areas and mitigations for ISPs and network operators to consider. Firstly, if you have and offer public Wi-Fi hotspots and use MAC authentication to offer seamless connectivity for subsequent visits, this capability will break and your customers will start to see a different customer experience, for example, have to re-register. One potential mitigation option here to you is to move to the use of Wi-Fi Passpoint and 802.1x, but this will require additional user interaction in terms of installing profiles. The second issue area to consider is if you're using device MAC addresses to aid broadband home device troubleshooting or Wi-Fi diagnostics, then this too could be impacted. Potential mitigation options here are the use of longer-term IEEE 802.11 physical layer identifiers or Wi-Fi Alliance certified Easy Connect. If you offer time-of-day internet access controls or parental controls based on device MAC address, again, these two will be impacted and you'll need to look at alternative solutions. And also a more wider reaching comment I have here is, this slide focuses on laptops, tablets, and smartphones, the main areas for today. But what about the impact of MAC randomization for the security and use of IoT devices too? So what can you do if you want to learn more about this? My top tips here is a good starting point is to start reading the output papers from the IEEE 802.11 RCM TIG working group. This gives a really good background to the history behind MAC randomization. Then I would encourage you to have a look at Apple and Microsoft's information and position on MAC randomization. Then start to identify your dependencies on MAC addresses. Where are you using them? And what mitigation options do you have for the changes which are potentially going to happen in the future? And also, lastly, talk to your operating system contacts and engage in the new IEEE 802.11 working groups. I understand that there may be a new working group which has been looked to be set up covering MAC randomization and wider Wi-Fi security in the IEEE 802.11. And lastly, talk to your operating system contacts on this topic. Lastly, before I conclude, I just wanted to flag some recent encrypted DNS and encrypted client hello developments, which are also worth checking out. Apple, again, through their recent developer conference, have highlighted their encrypted DNS plans for iOS 14. Also, there's updated IETF drafts for encrypted client hello, which is all about completing the encryption of the internet by hiding that site name, which is presently visible at the start of every HTTPS connection. Both encrypted DNS and ECH, encrypted client hello, continue to have the potential to cause unintended consequences to content filtering, cybersecurity, on-net content caches, customer support, and zero rating. I appreciate the impact from on-net content caching will vary by operator ISP, but for BT it could affect and make less optimal circa a couple of terabits per second that we cache locally. By zero rating, I'm referring here to the ability to identify and classify known content servers to exclude them from usage-based charging. And lastly on this slide, in terms of encrypted DNS and encrypted client hello, I would encourage ISPs and network operators to review these impacts and also engage in the IETF discussions on these, in particular the virtual IETF 108 meeting, which is starting this Saturday. So in conclusion, BT looks favourably upon new capabilities that enhance our privacy and security for our customers. However, whilst increasing privacy, further MAC randomization risks creating unintended consequences to customer experience and support. For example, potential impacts to public hotspot seamless MAC authentication, time-of-day access controls, device-based parental controls, and regulatory obligations. In a similar way, encrypted DNS and encrypted client hello privacy also come with impacts to zero rating, content filtering, and customer support capabilities. BT would welcome continued industry dialogue on balancing privacy features with the unintended consequences on the network and customer experience. Thank you for your time.
Thanks for that, Andy. Does anyone have any questions for Andy? If you could put them in the Q&A section. We've got something here from Ian Batten. A BT senior was unhappy when reminding him of form. when he said that the ISP aren't your enemy, but BT have formed for misusing plain text HTTP and DNS, and therefore it's slightly disingenuous to complain when people encrypt them.
I think that was 10, 12 years ago, so I think things a long time evolved since then.
Any more questions? Okay, oh, sorry. What is client support for Passpoint like? And that was from Ben Ward.
Okay, my colleague Simon Ringland's on, co-author of it. Simon, do you want to take that one?
One. Provisioning was defined. Their own. And Android will generally speaking.
Simon, I'm afraid there is an issue with your audio. We're unable to hear what you're saying. It's breaking up. Can you maybe try answering the question in the chat window? Okay, sorry about this. While we wait for Simon to get his audio back, do we want to go to the next question?
Yeah, this is possibly one for Andy. You say BT want dialogue. What solution do you think there is a good balance between privacy and the concerns you raise? What would you like to change?
I think certainly from a Mac randomization perspective, I think the best solution here is Passpoint. If we can find a way to minimize the impact that will have in terms of the customers in terms of installing Passpoint profiles and 802.1x authentication. I think longer term, I understand there may be new identifiers. We've added privacy coming out of IEEE, but I expect that's going to be several years downstream.
Okay, thanks, Andy. We've got a question from Dave Wilson. Given what you know of the planned implementation of device support for randomization and device release schedules, if you do you have a timeline for when this sort of thing is going to start biting in the world?
I think on this one is, I can't really speak for Apple and Google and others on this. So what I would encourage people to do is have a look and see what Apple publicly said in their videos, which I've attached links to around what capabilities they may add in iOS 14.
Great. And then just a comment from Hazel Smith. Just wanted to say thank you for your continued engagement with the DNS community. I saw your previous talk about DOT, DOH in BT and Deutsche Telekom environments. So just a comment there.
Great, thanks Hazel.